Videos ago, we looked at just how to figure out the number of SigFigs that are in a problem. The last video, we looked at how to round. Sorry, I thought the bell already rang. How to round to a certain number of SigFigs. So now what we're going to finally do is we're going to get into the math. And as we look at the math, we're going to do some simple math problems. You're going to want a calculator handy. It doesn't matter what type of calculator that you need. It does need to do scientific notation for this class. So if you don't have a calculator with scientific notation, I know that your math teachers had you download an app that looks something like this one or something like the TI-34s, but you're going to have to do scientific notation in some form or fashion. When we're doing math problems, you're going to do the problem as stated. Put all the numbers into the calculator, and then you're going to have to round your answer to reflect the amount of precision that the numbers had, the measurements had, when they went into the problem. So the math problems that we're going to do today, there's no units or anything like that. I did that to just tame it down, just to show you just numbers. But you're going to assume that all the numbers that we have today are measurements, because remember, measurements are the only thing that you use SigFigs for. If you are multiplying, I don't know, 3 giraffes by 4 apples, 3 times 4 is just 12. You don't use SigFigs, you don't have to round anything there. But we have to make sure that when we're doing our math problems, our accuracy and precision are being reflected in the answer that you're giving to the reader. So we have 2 more rules. One has to do with addition and subtraction. The other set of rules has to do with multiplication and division. We're going to go through addition and subtraction first. After we do that, then we're going to do the multiplication and division, and then we're going to mix it up in another problem. So I'm going to do some examples first of addition and subtraction, then with multiplication and division, and then put it all together in the very end. So when we're looking at addition and subtraction, you look at the, after you do the math problem, put it all in your calculator. You're going to look at the precision, and you're going to use the least precise number. What that actually means is you're going to look at your number of decimal places. The number that has the least amount of decimal places determines how you round your answer. So like looking at this example here, this one has 2 decimals, that one has 1, this one has 3. So when we do the math problem, you have to round your answer to only have 1 decimal place, the least precise number. So if you're doing addition or subtraction, either one, you're using the least precise number. The least precise number has the fewest number of decimal places. Now when you do these, if you have a whole number for your answer, whatever it is, so let's say that this had to be like a whole number of some sort. So this one was just 35, 36. When you get your answer here, if it ends in a 0, drop a decimal place at the end of it, because you're going to want to rescue those SigFigs later. You don't have to put a decimal place in the other ones unless you have to have a certain number of SigFigs, but when you're doing addition and subtraction, if the number ends in a 0 or a whole number, drop a decimal place. And that's going to help you to recover SigFigs later on if you have to do a different order of operation. So looking at these examples, I have them on a paper here. I just totally did that backwards, sorry. Okay, so looking at my example, I am going to get my calculator out, and you're going to do the problem in your calculator first. I probably don't need a calculator for some of these, but I'm just going to show you the full process just so you see everything. So this one says 3.5 plus 3.6665 and hit equals. So I did the math problem first. Once I do the math problem, then I need to figure out how I need to round it. This number has 1 decimal place, that one has 4, so my answer can only have 1 decimal place. So when I look at my calculator, I have to stop with the 7.1. The 6 next door makes the 1 go up to a 2, so my answer here is 7.2. Can only have 1 decimal place, and that 6 makes the 1 go up. The next one, again, I don't need a calculator for this, but I'm showing you the whole process. 3.0 minus 2.00. My calculator only says 1. However, I need to have 1 decimal place. That one has 1, that one has 2, so my answer can only have 1 decimal place. In this case, I'm going to write it out as 1.0. I have that one decimal place, which is what I need here, even though it's not written in my calculator here. This one says 36.58991 plus 7.44. My calculator says 44.02991. This number has 1, 2, 3, 4, 5 decimal places. That one has 2. My answer can only have 2 decimal places. So I have 44.02. The 9 makes the 2 go up. So my answer here is 44.03. The next one, 63 minus 52.66874. My calculator here says 10.33126. 63 has 0 decimal places. This one has 1, 2, 3, 4, 5 decimal places, which means that my answer cannot have any decimal places. So I need the 10 point. The 3 makes the 10 stay the same. So this one I'm going to have 10 drop a decimal place in because it's a whole number. So with addition and subtraction, you're looking at the least number of decimal places as your input numbers. Now on my multiplication and division, we are not using decimal places on these. You're using SigFigs. So the number that has the least amount of SigFigs is going to determine our answer. So you are going to look at your input numbers. When you look at your input numbers, you have to figure out how many SigFigs are in each of those, and then you round your answer to be the least amount of SigFigs as your input. So looking at these, again, we've got some practice problems here. With our practice problems, again, you're putting this in your calculator first. So when I put this into my calculator, I'm going to flip this around real quick. I have 3.2 times 5.10. My calculator says 16.32. To round my answer, because I'm doing multiplication or division, I'm using the least number of SigFigs. This number, 3.2, has 2 SigFigs. This number, 5.10, has 3 SigFigs. That means that my answer can only have 2 SigFigs. So I need to round this to only contain 2 SigFigs, so my answer here is 16. The next one, I have 63.2586 divided by 13.57. Again, I get an answer. I'm going to hold that in my calculator. This number has 1, 2, 3, 4, 5, 6 SigFigs. This one has 4. My answer has to have 4 SigFigs. So I need the 4.66. This 6 makes my 1 go up to a 2. So you get 4.662. And then the last one down here, 35.78 times 9, 322.02. This number has 4 SigFigs. This number has 1. That means that my answer can only have 1 SigFig, because the 9 only has 1. So I need the 3 spot. These 2's are going to turn into 0's. That still only has 1 SigFig because there's no decimal place present, but I had to keep the scale. If you only gave me an answer of 3, that is not the same as 300. So we have about 300 here when we're multiplying it out. Now to put this all together, some of these have scientific notation, some of them don't. But we're going to, again, use our calculator to do the problem. When we're looking at this, the first one says 3 times 5. I don't need a calculator to do that, but I'm going to show you what that looks like in your calculator. So 3 times 5 is 15 in your calculator. If we're using SigFigs in measurements, we have to round this to only contain 1 significant digit. So the 5 makes the 1 go up to a 2. So in terms of SigFigs, my answer is 20. So again, this is not where you do this in math class. 3 times 5 is actually 15. But when we're looking at estimation and precision, the answer is 20, because both of these answers, or these input numbers, are estimated answers. Now, if they got a little bit more precise and they said 3.0 times 5.0, that answer is 15. Again, looking at this, 3.0 times 5, that one has 2, that one has 1, that answer is 20. So that's why it is very important to measure things very precise in the lab, because you get very rounded answers when you don't. Okay, this one has scientific notation. To put scientific notation in your calculator, remember you're going to use the second, so second here, EE down here, and then just a 4. So that puts in the times 10 right there, that's the EE button. So 3.41 E4 divided by 4.5 second E6. Now this one, I'm doing multiplication and division. So when you do multiplication and division, you're using the least amount of SigFigs. So this one has 3 SigFigs, that one has 2 SigFigs. So you're going to only have 2 SigFigs in your answer. So you have 0.0076 is 2 SigFigs. 0 is the beginning of a number, never counts. The next one, 5863 divided by 2. This number has 4 SigFigs. This one has 1. Because we are doing division here, you have to use the least amount of SigFigs. So with this one, we are dividing. The 9 makes the 2 go up, so we'd have 3,000 here. Didn't do a very good job mixing these up. These are all multiplication and division. This one, I'm going to act like it's adding. I'm going to change this real quick. So when we add these two together, 6.3344 plus, can I change that one because I needed something addition and subtraction and I didn't do a very good job when I made up my problems. So when you add those two together, we're looking at decimal places now. When you add and subtract, you're looking at decimal places. That one has 4 decimal places, that one has 2 decimal places, so my answer could only have 2 decimal places, 9.09. So the big thing with these when you're doing the math problems, addition and subtraction, you're looking at decimal places to round. It's the least amount of decimal places. When you're doing multiplication and division, you have to figure out how many SigFigs are in each of your numbers, and then you're rounding to use the least amount of decimals. So I hope that helps. If you guys have any questions, make sure that you ask. Otherwise, have a great day.